Hello everyone and welcome back to the channel. Today we continue our adventure of exploring the Agent Tesla malware. This is part 2 of the series which we started a couple of videos ago. I will put the link to part 1 in the description below. In this video, we try to understand the final payload of the Agent Tesla malware. We will decrypt the strings which are encrypted inside the payload. We will find out the information it targets on the system and how it exfiltrates the data from the system. So let's dive in. So here I am in my virtual machine. I have this folder called Agent Tesla in which I have all these files. Last time we stopped at stage4.bin. Let me open the nspy and open this file. I think this is the file which is open from last time, but I will remove this and open it again. Stage 4, drag and drop here. Now when you open this file, you can see that the entry point is here. Click on it. When we click on the entry point, we can see very quickly something interesting. So this is a command which is checking whether a directory exists, and it looks for the environment variable, which looks like some kind of a function call. In it there is some kind of a static value being sent, which is concatenated with the same function call with another static value. Now this looks like string decryption to me. So here we have the same function u0005, and some strange operations are being conducted. Looking at this, so it looks like that there is some decryption going on here. We can go further down and we can look for further items like this. So again, get environment variable again, get environment variable again. So I'm fairly certain that this method is some kind of a string decryption routine. In order to get to those string values and decrypt those string values, we can use de for dot. De for dot has a feature which can be used to emulate the execution of a function, and after the emulation of the execution, the results are basically replaced back instead of that function call. So we go to this function first and we note down this token value of the function. So we have this. All right. Now let me minimize this and go to the data folder, go to de for dot. I will open this in Windows terminal and say /de for .exe, and after that I will give it the name of the file. The name of the file is stage4.bin, stage4.bin, and then I will say --str typ emulate --str tok, which is token, and then I will give it this function. And now we let it execute, and it has generated some kind of an obfuscator and given us back stage4-cleaned.bin. Press any key to exit, close this. Hopefully we don't need it anymore. And we have this file called stage4.bin. All right, now I will close the old one and open this new file again, dragging and dropping here, stage4. Now again, go to this main method. We can see that app data is here, and then that is concatenated with another string value, which is WNRUXJ. Let's just copy this value, copy this string. I will need it in the future. I want to make a backup of this from now so that I don't have to find it again. All right. So now when we look at this function has a lot going on, right? It is quite long. A lot of values are being checked, a lot of if conditions, try catch conditions, some case condition, for loops, etc., etc. So I don't want to waste my time going through all this analysis. So I will put a breakpoint here and basically start this execution of this program. Yes. So I will be using the keyboard to jump in and out of functions. So to give you a brief outlook on what I will be doing. So F10 will be used to step over the call of a function, and F11 will be used to step into a call of a function. So if we look at this first function, we have RU. Now, if I will press F11 here, I will go into this function, which is RU here. And this function is basically a wrapper to a sleep. The second thing that I can do is that edit this method, and I could say that this is a function called sleep. Okay. So that's it. And let it execute again using F10. Let me put a break value here. Continue. So basically it is sleeping for 30 minus 20, which is 10 seconds. All right. So F10 again. And we are back. All right. So what is TFX? Let's look at TFX. Getting the current process name, and I don't know what it is doing there. I don't need to, because it's not returning anything, and I don't see any significant actions being taken here. So that's fine. OZM, what is this function doing? All right, so I have an idea what this function is doing. It is creating an MD5 value and concatenating certain strings. What it is trying to generate is some kind of a UUID, which is like a unique identifier. So we'll skip over this and we'll look at the value of OGW after. So look, copy this. And this is like a unique identifier, right? All right, we go over this function and assembly location. So let's rename this to edit field. This is the current location. And OJL. What is this value? So another information which I wanted to let you know is that sometimes malware looks for specific locations and specific paths. The reason why they want to do that is to ensure that the malware itself is running out of a given path. And this is why this value of OGL is being generated. And in the future, in the code, you will see that this value of OGL is going to be compared with the current location. If both the values are not the same, then it will try to stop the execution and try to copy itself to that OGL location and try to execute itself from there. So what I will do is that just a few lines later, I will stop the execution, copy this file over to this location, and we will resume execution of the same code from this place. All right. So let me just rename this quickly, and we'll say expected location. OJS, what is OJS? This is basically the system name. So let's rename this. System name. Okay. Sleep again. Don't need this breakpoint. So now it will just keep on wasting time and just keep on going through this loop. And now it is trying to compare whether the current location is the same as the expected location. Let me just stop the code here and not spend more time analyzing this. I will copy the current executable over to the expected path, and then we will continue execution from there. All right. So now we are back at the start. We can keep on going. F10. It will sleep here. So sleep is finished. TFX was generation of a UUID. Oh, sorry, OZM was UUID, which we checked here. Now we'll go back. Expected location, current location, sleeping. So remember, we need to find out what is the information the agenttesla malware is going to extract from the system. Keep on going again. All right, so here something interesting will start. It's going down. So the steep is basically a diversion, right? It's just a way of evading the analysis. And all these switch are the same as well, just to evade the analysis. We will soon reach the location where we should go. Basically, we are looking to go here. All right, so this txr function is the one which is of interest to us. So here I will press F11 and we will go inside. So a new string is being generated, folder path is being extracted, a list is being created, etc., etc. This is the first piece of information which is being stolen from the system. So the Opera browser here, and then we have Citrio, 360 browser, Uran, Lebo browser, Elements browser, Epic Privacy, and we can go on and on. QIP surf, QON, 7-star, Torch browser, Cool Novo, etc., etc. Now, this can be a lot of information and a lot of code to debug and go through. So it's not really practical for me to go through all this information. Another way for us to extract this information is to export the code to a project, and we can say the folder, which is going to be the desktop. On the desktop, I will say something like code. Select this folder and just export. So once this is done, I can open up this folder in Visual Studio Code. And in it, I can look for something specific, right? So for example, I can look for list3.add. Looking for list3.add. So all these values are here now, and I can basically open an editor, and all these values I can see them, right? Another advantage is that hopefully if I can click here, it will take me directly to this value, which is awesome. All right, so quickly I can see that this is the information which agent Tesla is trying to extract from the system very quickly. Now next up, we just continue execution of this code and see what's next. So once I reach there, so let me put a breakpoint here. All right, so now it's reached here. We've just basically skipped past all this. We know it is trying to steal all this information. We've extracted those details. Now this is another piece of code which I don't want to debug. So let me put a breakpoint here, and it will come here eventually. All right, so this is another fun part. These are some of the other functions which are used to steal information from the system. So this is pop password. So what I can do is that I can add another string to look for in a Visual Studio Code, and we can see all these values as well, right? And we can see that it is looking for Incred email, it is looking for OpenVPN, and then WinSCP2, software Paltalk, and then Microsoft Outlook. And here it is trying to set up a run key, so which looks like a persistence, and then it is deleting the persistence value as well. So it looks like some sort of cleanup happening here, but this is all the information that it's trying to steal from the system again. So let me put a breakpoint at the end of the function. So it's trying to look for new accounts and whatnot. Let me go back and put a breakpoint here. Put a breakpoint here. All right. So this is fine. Again, DNB, it is trying to steal something from here. And we already saw that it is looking for these Microsoft Outlook profiles, which is fine. Next up, let's put a breakpoint here. Let it continue and go to YDJ. All right, so this is another string that we can use to find the information that we need. Again, I'll copy this, paste it here, and look for all the files whose text is being read. So Falcon profile, Claw RC, FileZilla, Purple, whatever this is. So if I don't understand what information is being targeted here, I can easily double click on this and it will take me to this place, right? So if I double click on this, it will take me to the piece of code, and here I can see that this part of the code is targeting the Pigeon application. All right. So we have 3 keys or 3 string values to search for, which will help us extract the information of the softwares which are being compromised. Moving along, I will press F10 again, DJW. Again, we have already copied this using the get folder path. I think we've done that. Let me just make sure. All right, so we have not done that. Let me put this here as well, and we see all these values as well. So it's trying to copy the Google Chrome information, Apple application support, UC browser, Microsoft Edge, Tencent, Falcon, clause mail, FTP getter, trillion, virtual store, and so on and so forth on Opera browser as well. So again, let me go back, press F10, VLR. So signons.txt. Again, I don't know what this means. I can basically Google this to find out. All right, so going back, VNK. Again, I already know that it is trying to extract the OpenVPN details. Thunderbird. So this is another string that I can use. So list.add range. Let me open this in the editor. And we have Firefox, SeaMonkey, Blackhawk, CyberFox, Chameleon, IceCat, all these things. So basically these are not foolproof. These are some of the tricks that I will use to extract all the information. The code is so big that it is not practical for me to go line by line and show you guys everything in this video. So it's just the tricks that we use to quickly triage and identify what is being stolen. So FRG, again, UC browser, we've seen this already, and so on and so forth. So we have FEA, JGZ, etc., etc. So all these things will obviously steal something from the user system. And I've shown you this as well. Get folder path will have extracted all these values. Now, the next thing that we want to look for is how does it extract all this information from the system, right? There must be a way to extract all these details from the system. As you can see, it is very thorough. It just keeps on going along and trying to extract the information from the system. So it's just going on and on. It's building some sort of an HTML here. And so we eventually this function finishes and we have this function called tam. And in tam we can see that a mail message is being created, a file name is being created with the HTML extension, and then a new mail address is here. A new mail attachment is being created, obviously, and some attachments are being added, credentials are being added, mail messages being created, and it will obviously be sent here. All right, so it is clear that this is the function which is used to extract or exfiltrate the data from the system. So we will go here and select the name of this function, edit the method, and say that this is exfil data. Right, exfiltrate the data. And the next thing that we do is that we try to track what are the places from where this function is being called. So right click on this, go to analyze, and you will see this tab open up, used by, and then we have this 4 places. Firstly, we'll look at tvj to see what this function is doing. So tvj is basically creating a memory stream, get random file, oza, ozc, all right, so this looks like something interesting. Let me go and see where this function is being called from. So this function is being called from the TXR method, which was the really long method, which was basically stealing the information from the system. So this method will be called, and let's see what are these values. So OZA, I can basically analyze this. So application data, OZA is app data, and OZC is something which must be generated on the fly. So I can go and analyze this. So analyze this assigned by this function. All right. So basically what it is trying to do is that OZC is a random file name, and this is OZW is the concatenation of the app data plus that random file name. So I understand what it is trying to do. It is trying to create some sort of a zip file which will have all the information. So zip file. So basically it is trying to create a zip file which will have all the information which it has stolen from the system. It will collect it in one zip file and send it across via the email. So that is fine. So we now know what is going on with that function. So let's go back. So we were looking at this function exfiltrate data, and this tvj function was calling it. Look at the tvz. What is this? So tvz is a function which looks like image decoder. I think I know what is going on here. It is trying to take a screenshot of the system. So I can say edit method, take screenshot, right? So the next thing is txr. This is the function which we were already looking at, which had all these list.add range values. We already checked out this function. And tvj, this tvj is basically operators.compare string, get temporary path, log.tmp. All right. I don't really understand what it is doing, but I don't see anything substantial here. It could be that this application is generating some sort of a log file. So it says if rg.odp, compare it to this, and if it is false, so I think this could be some sort of a logging which is being done, and it is being copied here. Again, not that significant. I don't really care. So we have 4 places where this exfiltrate data is being called from. So I can rename this function as well. So let me quickly rename this. Maybe log file extraction. Again, we saw that there was nothing substantial there. tvj was basically create and extract a zip file, create and extract data zip. So this is done. And the last one was the big function, right? So you can say go to start of this function. Steal info and sell. All right, so we're fine. So we now understand what is the information it extracts from the system, agent Tesla extracts from the system, and how it steals that information from the system as well. All right. So I think that brings us to the end of the video. Thank you very much for your time, and I hope to see you in the upcoming videos.